Good afternoon, calculus students. So, Mr. Chen again. So, today I would like to talk about section 9.2, part 2, which is considered the telescoping and geometric series for part of the infinite series. And when we know that a series converges, we do not necessarily know that the sum of the series. There are two types of series for which we can find the sum if the series converges. Okay, so one is considered the telescoping, so that's what we want to talk about first. So anytime they see the pattern like 1 over n times n plus 1, so the denominator just like keep adding the consecutive integer or multiplying the consecutive integer. So it's like 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 plus so on and so forth. 1 over n times n plus 1. So anytime that you see the pattern like this one is called the telescoping series. So another thing that we can do, if you guys do recognize partial fractions, decomposing, we can always break this one apart. We can always put it this way: sigma with n equals 1 to infinity of 1 over n minus 1 over n plus 1. So back to partial fraction, we do have like a over n and then plus b over n plus 1. And then you just solve for a and b here. So by the time you're doing the partial fraction decomposing, you'll see that a is just 1, and then b will be negative 1. Okay, so this one you can refer back to the other part of the video, partial fraction decomposition. So, and one thing that we can find out for this limit here, so this one you can always expand it into limit as n goes to infinity of 1 minus 1 half. Okay, so for the first term, I try to expand it out. So plus 1 half minus 1/3 plus so on and so forth. And then plus 1 over n minus 1 over n plus 1. So let's say that if I do have a natural number, so n is like 1, 2, 3, 4, 5, natural number, counting number. So this kind of pattern will give me the simple expression. So this one, if I just rearrange the term, so I do have 1 plus negative 1 half plus 1 half. So just collect the opposite term here. And then plus negative 1/3 plus 1/3. And then plus so on and so forth. And then plus negative 1 over n plus 1 over n. And then the final term would be 1 over n plus 1. Okay, so you try to rearrange the order of the term. So basically this one get cancel, all cancel out. So what's left here is just consider limit as n approaches infinity. I should put it right here. So it collapses to limit as n approaches infinity of the quantity 1 minus 1 over n plus 1. So if that's the case, so n goes to infinity, so plug in infinity here. So this one is 1 over infinity, which is 0. Subtract from 1, so finally the limit would be 1. So that means the limit for this one would be 0. And then the sum of this entire series, telescoping series, so that's 1. So the form is always given as n sigma I equals 1. So 1 over I, you can use n if you want to. And then times the quantity of I plus 1. So the nth partial sum, it's always 1 over 1 minus 1 over n plus 1. So for the partial sum. So your telescoping series converges if and only if a sub n approaches a finite number. A finite number, that means it's a definite number as n approaches infinity. If the series converges, the sum is always a sub 1 minus the limit of a sub n plus 1 as n approaches infinity. Well, which is true. That's what we just did it right here. So sometimes more than one term does not collapse. So if more than one term does not collapse, so that means you want to expand out more terms. So just write it out a few terms before deciding the term that you can rearrange so you can cancel them out. So here's the continuation of this section. So another part of the content that we need to talk about is this geometric series. If you guys do recognize the geometric series, it's always the pattern of a sub 1 times r to the power of n, with sigma as n equals k, so all the way to infinity. So again, n is just a natural number. So a plus a times r plus a times r squared plus a times r to the power of 3. So r is the common ratio. So where a does not equal 0, so two condition here. So if absolute value of r is greater than or equal to 1, so the series diverges. Well, because that is 1, the number, the sum is getting bigger and bigger. If the common ratio, absolute value of the common ratio, it's less than 1, the series converges. If the series converges, the sum could be found by doing this formula, a times r to the power of k, so where k is any natural number, all over 1 minus r. So consider the geometric series. So sigma as n equals 2. So instead of starting with n equals 1, we start with n equals 2. So all the way to infinity of this sequence, 4 times 2 over 3 to the power of n. If the series a, well, a, obviously, it's considered 4. Common ratio is 2/3. And what's the value of k? Well, depending on, the situation that we're looking for. So k could be any natural number, could be 1, 2, 3, 4, 5. But let's say that k is just like n plus 1. We just want to get the extra term. Okay, so does the series converges? Why or why not? Well, looks like the series will be converging. Okay, so this one, so it does, yes. And the reason why that is because the absolute value of the common ratio, so 2/3, it's less than 1. So therefore the series converges. If the series converges, what's the sum of the series? So by using the formula, so what we got here, well, got to be careful, instead of starting with n equals 1, so we start with n equals 2. So using that formula, so we do have a sub 1, if you recognize that a sub 1 over 1 minus r, because that is called the infinite geometric. So a sub 1, which is 4, divided by 1 minus 2/3. Now, not only you need to start it with with n equals 1, but you need to subtract that a sub 1, because a sub 1 is not part of it. You start with a sub 2. So a sub 1 by using the formula, which is 4 times 2/3. So we got 4 over 1 minus 2/3, which is 1/3. So 4 times 2/3, 1/3. So this one's 12 minus 1/3. So it's 36 over 3 minus a over 3. So that would be 28 over 3 for the sum. Okay, so again, the formula that you need to recognize, if the common ratio, it's less than 1. Absolute value of the common ratio is less than 1. It's always considered the infinite geometric series. And always guarantee that the series converges. Okay, because that the sum can be found. It's always being found as a finite number. If that's just like a regular geometric series, so the sum cannot be found if n goes to infinity. The partial sum can be found, but the infinite series, the sum cannot be found because common ratio is greater than or equal to 1. Alright, thank you for watching the video, so I'll see you guys next time. Take care. Bye.